The National Electrical Code, or NEC, does contain requirements that prevent the connection or support of an electrical system from a pipe that contains a combustible fluid. NEC Section 300.11c states electrical equipment shall not be installed in a hazardous classified location that is not suitable for the explosion characteristics of the specific hazardous material. Additionally, NEC Section 501.10b3 specifically addresses the use of pipes containing combustible fluids as a means of support for electrical equipment, stating piping systems containing flammable or combustible fluids shall not be used for the support of electrical equipment. This requirement is in place to prevent the potential ignition of the combustible fluid in the event of an electrical fault or malfunction. The key is to understand the potential hazards involved when combining electrical systems with pipes carrying flammable or combustible materials. Firstly, consider the risk of ignition. Any electrical fault, such as a short circuit or ground fault, can generate heat and sparks. If these sparks come into contact with a flammable or combustible fluid, it could lead to a fire or explosion. The NEC aims to minimize this risk by physically separating the electrical system from the fluid-carrying pipes. Secondly, the pipe itself could become energized in the event of an electrical fault. If the electrical system is directly connected to or supported by the pipe could become a conductor, posing an electrocution hazard to anyone who comes into contact with it. Thirdly, the presence of combustible fluids can exacerbate the damage caused by an electrical fire. If a fire breaks out in an area where these fluids are present, it can quickly spread and intensify, leading to more extensive damage and potential injuries. The NEC restrictions are designed to mitigate these risks and ensure a safer environment. Now let's delve deeper into the specific sections of the NEC that address this issue. Section 300.11, titled Securing and Supporting, provides general requirements for the support of electrical equipment and raceways. While it doesn't explicitly mention combustible fluids, it emphasizes the need for secure and reliable support methods that can withstand the stresses and vibrations associated with the electrical systems. The section also mandates that raceways, cable assemblies, and boxes be securely fastened in place. This helps to prevent them from becoming dislodged or damaged, which could lead to electrical faults. Subsection 300.11c specifically prohibits the installation of electrical equipment in hazardous classified locations if the equipment is not suitable for the explosion characteristics of the hazardous material. This means that if a pipe containing a combustible fluid is located in a hazardous area, any electrical equipment installed nearby must be specifically designed and rated for use in that environment. Such equipment is typically explosion-proof or intrinsically safe, meaning that it is designed to prevent the ignition of flammable vapors or gases. Section 501.10, titled Wiring Methods, provides specific requirements for wiring in Class 1, Division 1 and 2 locations. These are areas where flammable gases or vapors are or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Subsection 501.10b3 explicitly prohibits the use of piping systems containing flammable or combustible fluids for the support of electrical equipment. This is a critical requirement that is often overlooked, but it is essential for ensuring electrical safety in hazardous locations. The NEC also provides guidance on the types of wiring methods that are permitted in Class 1, Division 1 and 2 locations. These include rigid metal conduit, electrical metallic tubing, and cable types that are specifically approved for use in hazardous environments. The wiring methods must be installed in a manner that prevents the entry of flammable gases or vapors, and all connections must be made using approved fittings and connectors. Now let's consider some practical examples of situations where this NEC requirement would apply. Firstly, in a chemical processing plant, where pipes carrying flammable solvents are common, electrical equipment such as lighting fixtures, motors, and control panels must not be supported by these pipes. Instead, independent support structures such as dedicated unistrut channels or pipe stands should be used. Secondly, in a petroleum refinery, where pipes carrying crude oil and gasoline are prevalent, the same restrictions apply. Electrical equipment must be supported by separate structures, and all wiring must be installed in accordance with the NEC requirements for Class 1, Division 1 and 2 locations. Thirdly, in a manufacturing facility that uses flammable liquids in its production processes, such as a paint factory or a printing plant, electrical equipment must be kept separate from pipes carrying these liquids. This includes not only the support of the equipment but also the routing of electrical wiring. The wiring should be installed in a way that minimizes the risk of contact with the flammable liquids in the event of a spill or leak. It's important to note that the NEC is not a design manual, but rather a set of minimum safety standards. Therefore, it's always a good idea to go above and beyond the code requirements when designing and installing electrical systems in hazardous locations. This may involve using more robust support structures, specifying higher rated electrical equipment, or implementing additional safety measures such as gas detection systems and emergency shutdown systems. In addition to the NEC, other codes and standards may also apply to electrical installations in hazardous locations. These include the National Fire Protection Association, or NFPA, standards, such as NFPA 70E, Standard for Electrical Safety in the Workplace, and NFPA 496, Standard for Purged and Pressurized Enclosures for Electrical Equipment. It's important to be familiar with all of the applicable codes and standards to ensure that the electrical installation is safe and compliant. When designing and installing electrical systems in areas where combustible fluids are present, it's also important to consider the potential for corrosion. Many combustible fluids are corrosive, and they can damage electrical equipment and wiring over time. Therefore, it's important to select materials that are resistant to corrosion and to implement measures to protect the equipment from exposure to the fluids. This may involve using corrosion-resistant coatings, installing drip shields, or providing adequate ventilation. Furthermore, regular inspections and maintenance are essential for ensuring the continued safety of electrical systems in hazardous locations. Inspections should be conducted by qualified personnel who are familiar with the NEC and other applicable codes and standards. Maintenance should include regular cleaning, lubrication, and testing of electrical equipment to ensure that it is functioning properly. Any deficiencies or potential hazards should be addressed promptly. In summary, the NEC prohibits the connection or support of electrical systems from pipes that contain combustible fluids to prevent the potential ignition of these fluids in the event of an electrical fault. This requirement is found in NEC section 300.11c and 501.10b3. When working in hazardous locations, it's essential to be familiar with all of the applicable codes and standards and to take extra precautions to ensure the safety of the electrical installation. This includes using appropriate wiring methods, selecting corrosion-resistant materials, and implementing regular inspection and maintenance programs. By following these guidelines, it is possible to minimize the risks associated with electrical systems in hazardous locations and to create a safer working environment. Consider the specific type of combustible fluid present. Different fluids have different ignition temperatures and flammability characteristics. Ensure that the electrical equipment is rated appropriately for the specific fluid. Understand the area classification. Hazardous locations are classified based on the type and concentration of flammable materials present. The NEC defines different classes, divisions, and zones, each with specific requirements for electrical equipment. Ensure that the equipment you are using is approved for the correct area classification. Follow manufacturer's instructions. Always follow the manufacturer's instructions for installing and maintaining electrical equipment in hazardous locations. The manufacturer's instructions will provide specific guidance on how to ensure that the equipment is installed and operated safely. Use qualified personnel. Electrical work in hazardous locations should only be performed by qualified personnel who have been trained in the NEC and other applicable codes and standards. These individuals will have the knowledge and experience necessary to ensure that the work is done safely and correctly. Keep records. Maintain accurate records of all electrical work performed in hazardous locations, including the dates of installation, inspections, and maintenance. These records will be helpful in demonstrating compliance with the NEC and other applicable codes and standards. Review and update procedures regularly. The NEC and other applicable codes and standards are constantly being updated. It's important to review your procedures regularly to ensure that they are still in compliance with the latest requirements. Conduct regular training. Provide regular training to employees who work in hazardous locations. This training should cover the NEC, other applicable codes and standards, and the specific hazards associated with the work being performed. In addition to the specific requirements of the NEC, it's also important to consider the general principles of electrical safety when working in hazardous locations. These include always energizing equipment before working on it, using appropriate personal protective equipment, and following safe work practices. Always use the right tool for the job. Using the wrong tool can damage electrical equipment and create a safety hazard. Be aware of your surroundings. Pay attention to your surroundings and be aware of any potential hazards. This includes being aware of the location of combustible fluids, the presence of flammable vapors, and the proximity of other workers. If you are unsure about something, ask for help. It's always better to ask for help than to take a risk. If you are unsure about how to perform a task safely, ask a qualified person for assistance. Remember that electrical safety is everyone's responsibility. By following these guidelines and working together, we can create a safer working environment for everyone. Electrical safety in hazardous locations is a complex and challenging topic, but it is essential for protecting people and property from the dangers of fire and explosion. By understanding the NEC requirements and following safe work practices, you can help to minimize the risks associated with electrical systems in these environments. Let's discuss the broader context of electrical safety and its importance. Electrical safety is a critical aspect of any workplace or environment where electrical systems and equipment are used. It encompasses a range of practices, procedures, and standards designed to prevent electrical hazards such as electric shock, electrocution, fires, and explosions. The primary goal of electrical safety is to protect individuals from harm and to minimize the risk of property damage. One of the fundamental principles of electrical safety is to identify and assess potential hazards. This involves recognizing situations or conditions that could lead to electrical accidents. Some common electrical hazards include exposed wiring, damaged insulation, overloaded circuits, and improper grounding. Once hazards have been identified, it is important to implement appropriate control measures to mitigate the risks. These measures may include engineering controls, such as installing ground fault circuit interrupters, or GFCIs, and providing proper insulation, administrative controls, such as implementing lockout-tagout procedures, and personal protective equipment, or PPE, such as wearing insulated gloves and safety glasses. Lockout-tagout procedures are a critical component of electrical safety. These procedures are designed to prevent the accidental energization of equipment during maintenance or repair. The basic principle of lockout-tagout is to disconnect the equipment from its power source and to physically lock and tag the disconnect switch to prevent it from being turned on. This ensures that the equipment remains energized until the work is completed and the lockout-tagout devices are removed. Ground fault circuit interrupters, or GFCIs, are another important safety device. GFCIs are designed to detect ground faults, which occur when electricity flows through an unintended path to ground. When a ground fault is detected, the GFCI quickly trips the circuit, interrupting the flow of electricity and preventing electric shock. GFCIs are commonly used in areas where there is a risk of water exposure, such as bathrooms, kitchens, and outdoor locations. Proper grounding is also essential for electrical safety. Grounding provides a safe path for electricity to flow in the event of a fault. This helps to prevent the buildup of voltage on equipment and reduces the risk of electric shock. Grounding systems should be inspected regularly to ensure that they are in good working condition. Electrical safety training is a critical component of any electrical safety program. Training should be provided to all employees who work with or around electrical equipment. The training should cover the basics of electrical safety, including the identification of hazards, the use of control measures, and the proper procedures for working with electrical equipment. In addition to formal training, it is important to provide ongoing education and awareness to employees. This can be done through safety meetings, newsletters, and other communication channels. The goal is to keep electrical safety top of mind and to encourage employees to report any potential hazards. Regular inspections and maintenance are essential for ensuring the continued safety of electrical systems. Inspections should be conducted by qualified personnel who are familiar with the NEC and other applicable codes and standards. Maintenance should include regular cleaning, lubrication, and testing of electrical equipment to ensure that it is functioning properly. Any deficiencies or potential hazards should be addressed promptly. Electrical safety is not just a matter of following rules and regulations. It is also a matter of developing a safety culture within an organization. A safety culture is one in which safety is valued and prioritized at all levels of the organization. In a safety culture, employees are encouraged to speak up about safety concerns and to take responsibility for their own safety and the safety of others. Building a safety culture requires a commitment from management and the active participation of employees. Management must provide the resources and support necessary to implement effective safety programs. Employees must be willing to follow safety procedures and to report any potential hazards. Electrical safety is a continuous process of improvement. By constantly evaluating our practices and procedures, we can identify areas where we can improve and take steps to reduce the risk of electrical accidents. This includes staying up to date on the latest codes and standards, implementing new technologies, and learning from past mistakes. Electrical safety is a shared responsibility. We all have a role to play in ensuring a safe working environment. By working together, we can prevent electrical accidents and protect ourselves and our colleagues from harm. Now, let's consider some specific examples of how electrical safety principles can be applied in different settings. In a construction site, electrical safety is particularly important due to the presence of heavy equipment, temporary wiring, and changing environmental conditions. Some key electrical safety measures for construction sites include ensuring that all electrical equipment is properly grounded, using GSCIs for all temporary power outlets, and providing adequate lighting. In a manufacturing facility, electrical safety is critical for protecting workers from the hazards of automated machinery and industrial equipment. Some key electrical safety measures for manufacturing facilities include implementing lockout-tagout procedures, providing regular training on electrical safety, and conducting regular inspections of electrical equipment. In an office environment, electrical safety may seem less critical, but there are still potential hazards to be aware of. These include overloaded circuits, damaged extension cords, and improper grounding. Some key electrical safety measures for office environments include using surge protectors for all electronic equipment, avoiding the use of extension cords as permanent wiring, and reporting any electrical hazards to the facility manager. Electrical safety is not just a concern for the workplace. It is also important in our homes. Some key electrical safety measures for homes include installing GFCIs in bathrooms and kitchens, avoiding overloading circuits, and having a qualified electrician inspect your electrical system regularly. Remember that electrical safety is a continuous process. By staying informed, following safe practices, and taking responsibility for our own safety and the safety of others, we can help to prevent electrical accidents and protect ourselves and our families from harm.